All right, so here's the review. This is our first problem. It says light travels at a speed everywhere in the universe, since the beginning of the universe, by the way. And that speed is 3 times 10 to the eighth meters per second. Of course, it's also 3 times 10 to the fifth kilometers per second. But in this problem, we want to use meters per second, all right? Because, of course, they want to know what the answer is in uh, in meters. Oh, looks. Hey, hold on. I think something got cut off when I copied and pasted. All right, hold on just a second. How far does the light travel in 5.1? Sorry. All right. So this is I was supposed to paste that part. Oh, it might have deleted that. Sorry. All right. Anyhow, here I'm going to paste that right here. All right. There we go. So this is the actual problem: is how far in meters does the light travel in 5.1 seconds? All right. So this is the equation that we're going to use. Of course, it comes from this: the speed of light c is equal to distance divided by time. The distance. So whatever units of distance the light is in, then that's the distance of d. Right. Like in other words, if light is in meters per second, then the distance will be in meters. If the light is in kilometers per second, then the distance will be in kilometers. Right? That's just the way it works. All right. So, and then it says in 1 second, light would travel a distance of 3 times 10 to the eighth meters, right? Because, one times 3 times 10 to the eighth, that's, and then 2 times 3 times 10 to the eighth. Here, let me get my calculator over here. All right. So you would do, in 2 seconds, it would be 2 times 3 times 10 to the eighth. All right, so this many 600 million meters. All right, and then and so forth. Right, 3 seconds, 3 times that. But in this particular problem, they ask us what would it be if it was 5.1. All right, and so it's the exact same problem. All right, so oops, I didn't switch that. Okay, there we go. So we say so it's 3 times 10 to the eighth, right? It's supposed to be an 8 times the time. Of course, look, it's in meters. I'm going to show you that the units work out as well per second, and then times. So it's 5.1 seconds, right? So 5.1. That's a decimal. Seconds, and then the seconds cancel. I know my seconds sometimes look like fives, but it is seconds. All right, and so I get my handy calculator out, and this will be our first problem. All right, so clear this. All right, so 3 times 10 to the eighth times 5.1. All right, and so what we're going to do, the problem on the test would already say how many digits to round it past the decimal. But let's say I say let's round it 2 places past the decimal. Okay, so that's the answer. So on Blackboard you would write. I'm going to do it just like it was Blackboard. So it would be 1.53. All right, let's see. So now I got to count the zero. Count where the decimal point was. There it is. All right, so I got 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So times 10 to the ninth, right? But of course, in Blackboard, you don't write times 10 to the ninth. You write capital E. Come on, capital E, and just 9. All right, no spaces or anything like that. So that's 1.53 times 10 to the ninth, which of course is that's exactly like that. That's what that number is, right? It's just putting this in a language that Blackboard understands. All right, let's look at the next problem. All right, so this is the second problem. Let's move that just, oops, didn't mean to do that. All right, anyhow, so this is the second problem. All right, so it says the baseline is measured to be, all right, so this is what B is. B is 2,150. All right, so I'm just going to write these numbers down. Okay, so B, oh, come on, B, oh, what is it doing? hold on. All right, that's a little better. Okay, so it says the baseline is measured to be so it's 2,150 kilometers, and the parallax of this the parallax that this object makes with the baseline, of course, is 15.2. And remember, the two hash marks means arc seconds. All right, and so we want to find the distance. Well, we need to know the conversion between arc seconds and arc minutes, and then arc minutes to degrees, right? Because in the equation, all right, so here's the equation. All right, come on, there we go. The distance is equal to 180, and of course that's 180 degrees. That's supposed to be an 8, divided by pi, just the number pi, and then times, so I'm just going to put that in parentheses artificially. All right, so anyhow, times the baseline divided by the parallax, where whatever the units of the baseline, here, let me use the mouse here. So whatever the units of the baseline are, that's also what the units of the distance are going to be. And the parallax has to be in degrees. Right? So really that's all we have to do is convert this from arc seconds to degrees, which is pretty trivial. That's a small number of degrees, right? So here we go. So the parallax is equal to, so of course, we do the same thing that we always do with conversions. We look at our conversion factors, right, which are these things up here, right? So the first one we're going to use is this one. So the first one is 60 arc seconds, because the arc seconds have to cancel. Remember, the two hash marks as arc seconds is 1 arc minute, and then you got, so this cancels this, and then we know that 60 arc minutes, so that's 1 hash mark, is 1 degree. That's a degree, sorry. That's supposed to be a circle. All right. And so of course anyhow, so those the arc minutes cancel. All right. So let's get our handy calculator. We'll clear this from the last problem. All right. So this is the angle. It's going to be 15. What is it? 0.2? 15.2 divided by 60 squared, right? And that, so there. So that's the angle. It's really small, right? So the angle, let's round it to, let's see, 1, 2, 3, 4. 4 places past the decimal. How's that? So the parallax would be 0.0042, right? Because the 2 repeats. All right, so anyhow, let's do the distance. All right, so the distance is going to equal 180 divided by pi times the baseline, which was 2,150 kilometers. All right, remember this is degrees, by the way, and then that's the 180 is degrees, and then what was it again? It was 0.00. Let me look at it on the calculator real quick. Well, see, that's already in my calculator. So 0.0042. Right. So that's 0042. All right. And of course, that's degrees as well. And of course, the degrees, that's supposed to be canceling. The degrees cancel, and that leaves you an answer in kilometers. All right. So here, let's do the problem now. And we're almost done. Let's see. So I already know what that number is. So that'll be in my calculator. So I'm going to say, so it's going to be 180 times the 2150, and then So now what I'm going to do is, I'm going to divide. Notice I got 2 things in the denominator here, right? So I'm going to divide by, so in parentheses, pi, right? So I'm dividing by pi, and then times, so the pi is going to be times 0.0042, right? To use the rounding that we use, all right? And then close parentheses. All right, and then this will give me my answer. So this is how far away this thing is. Okay, remember this is in kilometers. So here, let's put it in scientific notation and round it to 3 places past the decimal. All right. So I mean this is the number, right? It's 29,329,982.3 blah 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 blah. Right? It keeps going. But if we round it, so if we turn it into scientific notation, it becomes 2.9. All right. So 2 places past the decimal would be, so it would be 2.9, right? And then, that's a decimal, sorry. 2.9. And then if you look at the, 2 places past the decimal, the place after the, so 2.9 is 2.93. And so the thing that's after the 3, is a 2, and so you would just you don't round up, so it'd just be 2.93. Oops, come on, 3. Let me do it. Sorry, let me do it so that it's going to be, of course, times 10, but let's not write it times 10. Let's do it. Come on. Stupid thing. There we go. All right, so E, and then now I just count where the decimal is, right? So I'm just going to see where it is. Okay, so this is, so there's the decimal right there, 1, 1, 2, 3, 1, 2, 3, and so E7, right? Positive 7, right? So times 10 to the 7th. All right, so that's what you would enter in your calculator. All right, very nice. All right, and here's our next 2 problems. Actually, let me get the calculator ready to go here. All right, so here's our next 2 problems. How many degrees is in 50.4 arc minutes? All right, so again, you just need the conversions. So here, I'll write them one more time. Let's see, so one degree is equal to 60 arc minutes, and then here's the other conversion. 1 arc minute is the same as 6. Oh, it's going to go off the page here. 60 arc seconds. So there's 2 hash marks. All right, sorry about that. I ran off the page a little bit. All right, and so let's convert this, and then we'll convert the other one. All right, so these are 2 problems. This is really pretty straightforward. So we have an angle here. I'll just write it as an angle theta. It doesn't really matter what you call it. So it's going to be 50.4, and remember, arc minutes can also be written this way. And then, of course, you always use, it's always some fraction, and what goes in the denominator, it has to cancel what's already up here, right? So we just look here and you say, all right, I'm changing it to degrees. So there's the conversion I want, is degrees to arc minutes, right? And so one goes in the numerator, 1 degree, and divided by 60 arc minutes, right? And of course, the arc minutes can't. You don't have to. You can just doing this to show that these 2 cancel. All right, and so 50. So it's going to be a number less than 1. So here, let's break out the calculator and clear this one. All right, so here we go. So it's 50.4 divided by 60. That's literally it. All right, so it would be 0.84 degrees. All right, so 0.84 degrees. All right. So in Blackboard, you would just type 0.84. Right. So you don't have to type the 0, but I'm just used to doing it. All right, so that's our first one. We'll call that theta 1. And then theta 2 is a different one. Theta 2 is 2,214.5, and it's arc seconds. And so we got, it's just basically 2 conversions. Okay, so we're going to start with this one. We know that 1 arc minute is 60 arc seconds. I'm not going to bother to, well, here, just because I started doing this, I'll do it again. And then, of course, one